So good afternoon, everyone. I am Animesh Mohan, and this is a demo of the project that we're working on this summer. So, so the problem statement that we are trying to address is one that nonprofits often come across. The process of vetting the standing of a person and trying to determine if they have any red flags. The approach that they're currently using, where they, like you mentioned, go through everyone's social media, is quite cumbersome and can take a lot of time. So the aim of our project is we want to simplify this process and automate it. So we thought of doing this by building a web app that goes through a person's social media and generates a risk score and tries to catch any red flags that it might generate. There are a lot of pets in the USA, and so the time that each adoption agency takes can vary from 20 minutes to 2 hours, and they receive a minimum of 1,500 applications a year, so which is very, very hard for them to keep up with. So this was one of the important motivating factors that inspired us to go ahead with this project. So our full stack application consists of React, MongoDB, and Django. So one of the reasons we chose to go ahead with MongoDB was because it's really easy to scale and easy to manage. And also, that's one of the reasons why we chose Django, because Django helps us by giving us the ORM. It's very easy to use and integrate with Mongo. And the reason we use React is because it makes it easier for us to render web pages dynamically.
Okay, so once we extract the data from social media accounts, we need a way to calculate the risk score. And we used a bidirectional recurrent neural network with GRU to do this. And the dataset we used is the Kaggle dataset, which is part of the Toxic Comment Classification Challenge. In the dataset, Wikipedia comments have been labeled by human raters for toxic behavior. And there are 6 classes with different types of toxicity, which are toxic, severe toxic, obscene, threat, insult, and identity hate. And the model outputs a value between 0 to 1 in each of these categories. For the pre-processing part, we first converted the text to lowercase, and then we removed links and numbers, and we handled abbreviations and removed special characters and stop words. So, like I said, we used a bidirectional recurrent neural network with GRU. We also used GLOVE word embedding. So GLOVE stands for Global Vectors, which is an unsupervised learning algorithm for obtaining vector representation of words. So for example, words which are similar in meaning are close together in the vector space and vice versa. And these are useful when training on data that can benefit from contextual information. We also trained our model using k-fold cross-validation, and we picked the best model out of this. And we implemented early stopping such that the model doesn't overfit on the training data. And these are the specific layers for the model. Yeah.
Okay, so our backend Django project consists of 3 applications most as of now. So the authentication app, the scoring app, and the APIs app. So this is the workflow of our project so far. So what the authentication app focuses on is trying to get the user to authorize our app to access the data on social media. So basically, we ask the user to log into their account and authorize our app. And as soon as they authorize their app, our app receives the access token, which it encrypts and stores in the database. And then the scoring app focuses on fetching these access tokens from the database, decrypting them, and using these access tokens to fetch data from Facebook and Twitter. And this data is sent to the it's pre-processed and then fed to the model. The output of the model is then used to calculate the risk score, which is then stored back in the database. And that's where the API app comes in. So the API app basically queries the database, and this query set is basically serialized and rendered at various endpoints, which the front end uses to display the data.
Yeah, and for the front end, we used React.js, which is an open source JavaScript library for building UIs. And we also used Antitype, which is a popular React framework, which comes with predefined components. So it made our work easier. We also used D3.js for dynamic and interactive visualizations. I'll just show you the demo.
Yeah.
Okay, so first, go to the local, go to a link which the animal adoption agencies send to potential animal adopters. So using which they can log in to their Twitter or Facebook or both. So when I click on login with Twitter, I enter the username and password. And then, so when I do this, I'm able to fetch the access tokens, which I store in the database. And I do the same thing with Facebook. Yeah, so this is what potential animal adopters see, like the users. And also, so we also built a dashboard for animal adoption agencies for them to view the potential adopters and their risk scores. So this is what the dashboard looks like, where the list of users are displayed along with their risk score. And and also some analytics. So for example, we've converted the risk score into a percentage. We're displaying it in the form of a donut chart, and we're also displaying the global average risk score of all the users. And so this is important, like if you want to compare how closely related the risk score is to the global average. We're also displaying a line chart with the risk score for each year, and we're able to display how the risk score varies throughout the years. So we thought this might be another useful analysis as well. And we're also displaying a bar chart with the risk score for each categories. And to make it more visually appealing, we're incorporated some animation as well. This is what we have for now. We might add some more analysis and charts. Yeah, that's about it.
Awesome. And then what about, so how's the risk score computed? I know that we had a couple of Slack exchanges about that. Can you talk a little bit about that?
Yeah. So we're getting the risk score for, so we're getting the model outputs a value for each of these 6 categories, which is a value between 0 to 1. And we're calculating the weighted average of these 6 categories. So, and we're deciding the weights based on the severity of each category. For example, severe, toxic, and obscene, severe, toxic, and threat have higher weights. And after that, we're just calculating the average of all. We calculate the risk score for each post, and then we find the average of all of that to find the final risk score.